Number 2, at time t, the position of a particle moving in the xy plane is given by the parametric functions x of t, y of t, where dx dt equals t squared plus sine of 3t squared. The graph of y, consisting of 3 line segments, is shown in the figure above. At t equals 0, the particle is at position 5, 1. Part A says to find the position of the particle at t equals 3. So if we want the position of the particle, since it's a parametric function, we're going to have an x value and we're going to have a y value. So we want to find both of those, all right? We know that for the x value, we know the derivative of x. So to get where the particle is at t equals 3, there are 2 things we're going to do. First of all, we're going to consider where the particle started at. The particle started at 5 in the x direction, and then we're going to find the change in distance from 0, change in position from 0 to 3. So we're going to take, to get rid of the derivative, we will take the integral. So we're going to take the integral from 0 to 3 of dx dt, which will be 5 plus the integral from 0 to 3 of t squared plus sine of 3t squared dt. Okay, when we do that, now from here we can just use math 9, and we'll get 5 plus 9.377. So the x value of the particle's position will be 14.377. The y value, they told us that this is the graph of y. So if I want to know the position at t equals 3, let's just go over to t equals 3. And if we look at that, it looks like that is at -1/2. So the y value of that one will be -1/2. So my position is going to be 14.377, comma, -1/2. All right, that was worth 3 points. If you found an integral or set up an integral, so if you did this part right here, that would have been worth 1 point. If you use the initial condition of the 5, so you knew where it started at, so if you added on the 5, you'd also get 1 point. And then if you got this final answer of both of those, you'd get your 3rd point for that problem. So this part was worth 3 points. Okay, part B says to find the slope of the line tangent to the path of the particle at t equals 3. So if we want to find the slope, we want to find the derivative. So we want to find dy dx. So to find dy dx, remember the formula for that is going to be dy dt over dx dt at t equals 3. And so to get dy dt at t equals 3, if this is a graph of y, we want to find the slope at t equals 3. So at t equals 3, it's right here. If I want to find the slope of that line, I notice that it's up 1 over 2. So the slope of that line is going to be 1/2. So dy dt will be 1/2. dx dt, I can just actually plug in 3 into the dx dt formula. So this will be 3 squared plus the sine of 3 times 3 squared. And when I figure that out, it's going to be 1/2 over 9.956376. Remember, if we're going to round, we want to round like to 5 places in the middle of our problem at least. And then when you figure that out, it ends up being 0.050. So that one was worth just 1 point. All right. Part C, find the speed of the particle at t equals 3. Okay, we found out that the speed is equal to the square root of the derivative of the x at 3 squared plus the derivative of the y at 3 squared. So we have already found out that the derivative of the x was 9.956376, and then we're going to square that. Plus, we found out that y prime of 3 was 1/2, and then we'll square it. And then when we find that answer out, it will be 9.969. All right, so that was worth 2 points. If you have an expression for speed, so if you have this right here, that would be worth 1 point. You could also have dx dt of 3 squared plus dy dt of 3 squared. And then if you have your proper answer, that would also be worth 1 point. So this part was worth 2 points. Okay, and then part D, find the total distance traveled by the particle from t equals 0 to t equals 2. We're going to use our distance formula. The distance formula is the integral from 0 to 2 of the square root, pretty much, of the speed. So it's going to be x prime of t squared plus y prime of t squared dt. And then when we do this, I should end up getting from 0 to 2. So if I'm going, just one quick comment on this one, when we are doing D, we have the formula, we can just put the t squared plus sine of 3t squared in here. So we're just going to use that formula for that part because that is dx dt. For this one though, we do not have a formula for y prime, but if you notice from 0 to 2, actually I'm just going, oh, guess what? 0 to 2, if you look at this, we have an issue because y prime is different for each of those. From 0 to 1, it's one thing, and from 1 to 2, it's another thing. So we actually get to split this one up. So I'm going to take the 0 to 1 of x prime of t squared plus y prime of t squared, and then add it to go from 1 to 2 with the square root of x prime of t. They always seem to throw in some crazy trick going on here. Okay, so y prime of t going from 0 to 1, that slope will always be -2. Okay, so we don't actually, are not going to put a formula in there for that, we're just going to put -2. Okay, and then going from 1 to 2, y prime, the derivative or the slope here from between 1 and 2 is always 0. So now we'll go ahead, now from here we can go ahead and type the math 9 in our calculator, and when we do that we will end up getting a distance of 4.350. Okay, so that was worth 3 points. If you have an expression for distance, which is right here, and actually that is an expression for distance, so that would be worth a point. Okay, now if you split it and you have two integrals, we are going to have 1 point, and then for your final answer you will get 1 point. So that part was worth 3 points.